A very good morning to all of you. Myself Suman Garg, working as a lecturer in C department at BHS BIT Laragaga. Today I will explain the topic that is from computer graphics, subject of diploma 6th semester CE and IIT common. The topic is scan conversion and the scan conversion of a line specially. The circle and polygons etc. that will be explained in the later on lectures. My topic is only to explain the line drawing algos. So these are the various contents I will cover through my lecture. First of all, I will tell you the what are the output primitives. These are the basic geometric scenes, basic geometric structures which we can describe from a scene. When a scene is described in form of geometric structures, that may be called as a output primitives. So that how we can see the overall images on the screen on the output devices like your monitor, your any of the device output device. The output primitives may be your points, lines, and with the combination of lines we can draw the we can have the polygons, we can have the hexagon and many more types of shapes, and there may be arcs, types of arcs. With the arcs we can create the circles, ellipses, parabolas, and various other structures. So these all are the output primitives with the help of which we can make the various geometric structures. And for drawing of a point, there are various options. For to convert a point in a pixel, we have to estimate the exact integer value that so that we can draw that pixel. For that there are various functions I will tell you later on in the lecture. Then there are point operations. What kind of operations we can apply on the point, we can apply on the line. We can set a intensity value of the point and we can get the intensity value of the point if it is already settled down. We can draw a line, we can draw change the width of the line, color of the line, and we can rotate the line, and we can also apply all the transformations on the line and all other output primitives which we can draw with the help of line. Next, then the rasterization will be explained, that is the scan conversion, how a continuous image space can be explained, can be described in the form of digital image space. Continuous image can be described in the form of digital image, that means in the form of pixels, how many pixels will be on and which kind of which pixels will be on and which pixels will be off on the screen. This is called rasterization. Then the line symmetry can be used if we have drawn a line for all the positive slope area. Then for negative slope area we can we can use the line symmetry. We need not to calculate all other points if we have drawn the positive slope line. How it will be used I will tell you. Then the line drawing algorithms, there are basically first of all the line can be drawn with the help of slope line equation, that is the equation of line y equals to mx plus b. M is the slope of line and b is the y intercept. Then this equation of line draws a line very good, but it involves various multiplication operations, floating point operations, etc. And to improve the performance of line drawing, there are two other algos which are DDA, digital differential analyzer algorithm. DDA is the differential analyzer is a one kind of physical machine which is used to calculate the differential equations. Further, this machine's idea is used in developing the digital differential analyzer algorithm which is used to draw the straight lines. Then there is another algorithm, that is Bressenham lines algorithm, which involves only the incremental calculations. There is no multiplication in this algorithm and there is no floating point, round off, etc. operations in this algorithm. So this is the fastest method of line drawing. So first of all, what are the 2D primitive output primitives? there are various graphics packages which provide basic operations like your primitive operations, which are the very basic operations to describe a scene in terms of geometric structures. In terms of geometric structure, these geometric structures are called the output primitives. The following are the sum of these primitives. First of all, there is a point, set a point on or off using its intensity attributes. Then there is a line, we can draw the line with the help of graphics packages. We can draw the polygons, we can draw the arcs, and with the help of arcs we can draw the circles, ellipses and parabolas, etc. Then point operations, what kind of operations we can apply on the point? We can there is a set pixel operation with the parameters x comma y comma intensity. X and y are the coordinates of that pixel, and intensity is the attribute that is to be set of that pixel, about that pixel. This operation turns the pixel at the position is described by x comma y coordinate. This operation turns the pixel at the position on and sets its attribute intensity. There are various attributes like color, their density, illumination, texture, and one of those is attribute intensity to the intensity value that is given in the parameter by word that we can see intensity is there. Assign the point with the coordinate x comma y to a variable used as the current point. We can get this point as the current point, then we can use this operation set pixel to on the intensity of this coordinate, that is x comma y. Then there is next operation, that is get pixel xy. Get pixel, if we want to return the intensity of any pixel, then with this operation we can do so, an operation that returns the intensity of the pixel at position that is described by x comma y. Any point that is already its intensity is on or off, whatever its intensity that we can get with this operation, that is get pixel xy. With this of this pixel, what is at this pixel, what is the intensity that we can get with this operation get pixel. Then there are line operations. Line, the first operation, how to draw a line. There are various line drawing operations, but the parameters are different. Sometimes we know the two endpoints of the line, and sometimes we know only the one point, and the next point will be current point. We know current point, that is under the cursor of the screen, and the next point up to which we have to draw a line, that will be explained in the parameters. The first operation, that is line, that is line. The parameters are x1 y1, the coordinates of first point, x2 y2, the coordinates of second point, and this is the intensity parameter that is to be set on, and this function, this operation draws a line between the 2 points which are described with this x1 y1 first point coordinate to x2 y2 second point coordinate. It draws a line between the 2 points which are described in this parameters x1 y1 x2 y2. The pixels are set to the intensity value equals to this intensity parameter. Then there is a next function, that is line 2. In this function we will draw a line between the 2 points, the current point and the xy point. Xy point is given in the parameter, and the current point at which the cursor is already here. The line will be drawn between the 2 points, the current point and the xy, and the intensity value of that pixel is set to the intensity parameter that is given in the function already. Line REL, it will draw a line delta x delta y. It draws a line between the 2 points, the current point to a new point, current point where the cursor is placed, and the new point will be calculated as current dot x, matlab current point plus delta x and current dot y, that is the y coordinate of current point plus delta y. The next point will be calculated within the operation itself. These are the two parameters which are given in line REL. it will draw a line between the 2 points, the current point to a new point. That new point will be calculated with this delta x and delta y. Delta x is a change in value of x from the current point to the next point, and delta y is a change in value of y from the current point to the next point. Then the rasterization, that is scan, also called scan conversion. It converts the high level geometry description to pixel colors in the frame buffers. We have a description of any of geometry, that is just we have a shape of any scene. This rasterization will convert those high level geometry description to the pixel colors in the frame buffer. As our monitor screen, output screen is a combination of pixels, that is in the vertical direction and in the horizontal directions, and we are on the overall screen, we are to set the pixels to so that our screen may show a required geometry description. So this rasterization is a conversion of high level geometry description to the pixel colors in the frame buffer. Frame buffer is one kind of memory area where the intensity values for all the screen pixels are stored there. So for example, given a vertex with xy coordinates, determine the pixel colors to draw lines. We are given a vertex with the xy coordinates, we have to determine the pixel colors to draw line. There are two ways to create any of the image. First, we can just directly scan the existing photograph by use of any of the scanning device, that may be scanner, that may be your photo device, photo cameras are there. We can directly input our existing photograph into our computer system. So this is one of the way to create an image. And the second is, we have a geometric description. We have to draw that image onto the monitor screen by a use of rasterization. So for that, there is a procedurally we have to compute the values of all the pixels which will be on and which will be off, so that we have the exact geometric description from the high level. So there is a process how this rasterization converts the viewport transformation to the exact digital image, that is the number of pixels that are on, number of pixels that are off. On and off are used in the monochrome systems where only two colors are used, black and white. Black means on, if the screen is black, overall screen is black, if there is any pixel white, it means that is on. If the screen is background is white, then the black means that is on and off. Then if there is a colored monitors, colored output devices, then the intensity colors can be changed accordingly. Then rasterization, this is a fundamental computer graphics function which is used to draw the lines, the output primitives, the arcs, etc. Then it determines the pixels colors, illuminations, textures, etc. And this is implemented directly by the graphics hardware. The drawing exactly on the screen is implemented by the graphics hardware. Maybe that is a CRT beams, maybe that is electron gun, maybe that is a LCD, etc. Then the rasterization algorithms are used to draw the lines, circles, triangles and polygons with the different colors or with the different illuminations, etc. Then the rasterization operations, how this rasterization is used in various operations. With the rasterization, we can draw the lines on the screen, we can manipulate the pixel maps, copying, scaling, rotating, transforming, all the transformation we can apply with the help of rasterization. We are to change the position of one line, one output primitive from one place to another. Now, for that we can do that with the help of rasterization. Compositing images, defining and modifying regions with the help of rasterization. Drawing and filling polygons, with the help of rasterization we can draw polygons, and with the help of rasterization also we can fill the regions between the polygons, whether that is a flood fill. There are two policies that is flood fill or boundary fill. We can start from the boundary, we can start from the central place. This is a topic later on covered in next lectures. Then there are aliasing and anti-aliasing methods. Before starting the line drawing, actually I just want to give you a basic math review. That is, first of all, for a line there is a slope intercept formula. Given a suppose there is a line, you can see that there is a line from P1 to P2. P2 there are 3 points, P1 with the coordinates x1, y1, P2 with the coordinates x2, y2. For the third point, suppose the third point is described by x comma y. We don't know these values. What are the exact values of x comma y? For the calculation of this point, we have a slope intercept formula. The slope of the line, okay, how much slope of the line is defined as how much inclined this line is in which direction. Slope of the line is defined as the difference between the y points, y minus y1 upon divided by x minus divided by the difference between the x coordinates, or we can say slope is also defined the rise in the y direction upon the run in the x direction. So, the slope can also be calculated for this example. The difference between the y coordinates of these 2 points upon the difference between the x coordinates of these 2 points, y2 minus y1 upon x2 minus x1. So, for solving for y from these equations, both these equations are equal. Y is equals to y2 minus y1 upon x2 minus x1 into this x minus x1 will be cross multiplied, and so that we will get y2 minus y1 upon x2 minus x1 multiplied by x minus y2 minus y1 upon x2 minus x1, it will be multiplied by x1, and this y1 will be added upon the opposite side, or we can say y is equals to mx plus b, where m is the slope of the line which is defined as y2 minus y1 upon x2 minus x1, or we can say rise in the y direction upon run in the x direction, horizontal direction, and b is the constant, b is the y intercept. Y intercept means where that line cuts the y axis, where this line will intersect the y axis, that point will call the y intercept. The value of y intercept can be calculated from this is minus y2 minus y1 upon x2 minus x1 into x1 plus y1. These are some other helpful formulas which we can use for defining the length of line segment between the P1 and P2. What is the exact length of line? It can be calculated as x2 minus x1 square plus y2 minus y1 square under root of the whole. Then the midpoint of line segment between the P1 and P3, suppose this is P3 and this is P1. What will be the midpoint? Which pixel will be the midpoint between these 2 points? That can be calculated as x1 plus x3 divided by 2. It will provide you the x coordinate, and y1 plus y3 divided by 2. It will give you the y coordinate of the midpoint. The two lines are perpendicular if and only if the slope of the first line is equals to minus m by minus 1 divided by slope of the second line, or we can say the cosine of angle cos theta between the two lines is 0, then those two lines will be perpendicular. Then this is another definition, another equation of line in the parametric form with the use of parameter t, that is given 2 points. Suppose we are given 2 points x1 y p1 and p2 with the coordinates again x1 y1 x2 y2. So, x will be defined as x1 plus, this is the t parameter, x2 minus x1, and y is equals to y1 plus t is the parameter, y2 minus y1. The value of x and y will be calculated as x1 x could be equal to x1 or x2 depending on the value of depending on the value of parameter t, and similarly y can be equal to y1 or y2 depending on the value of parameter t. This parameter t can range from 0 to 1. With this parameter we get all the other points on the line segment between the x1 y1 and x2 y2. If we are given two endpoints of any line, in between all the points from x1 y1 to x2 y2 we can get with the help of this equation. When this t is 0, we will get the x equals to x1 and y equals to y1, because t portion is 0, the second portion will be almost 0. And in this similarly, when t is equals to 1, it will become x equals to x1 plus x2 minus x1. x1 and x1 will be cancelled out. In that case, your x will become x2 and y will become y2. So, where to draw this line? If we are given a 2 points, then where to draw that line? This line drawing is accomplished by calculating the intermediate positions. We are given 2 points, intermediate positions are to be calculated along the line path between the specified endpoints. So, definition of line drawing can be as follows. Given 2 points P and Q in the plane, both with integer coordinates, determine which pixel on a raster screen on those 2 points. We are given 2 points, these are the integer coordinates with the integer coordinates x and y, x1 y1, x2 y2. 4 coordinate values will be integer only. So, we are to determine which pixels on a raster screen should be on in order to make a picture of the unit width line segment starting from P and ending at Q. From P to Q, which pixel will be on and which pixel will be off, so that we will get a picture of unit width line between the P and Q. Suppose there is a line, there is a pixel. Pixels are defined as the square area. This is a intersection of the scan lines as well as a vertical lines on the screen. There are the x coordinates xk plus 1, xk plus 2, xk plus 3, and the scan lines yk plus 1, yk plus 2, and so on. This is the first pixel, that is xk yk. This is the first pixel xk yk, and from this pixel up to the next last pixel, which pixel will be on during this line segment. At section of this is an example of screen showing a pixel in the column xk on the scan line yk, that is to be plotted along the path of line segment with the slope 0 to 1. A line segment, line drawing, that is the thinnest line is of 1 pixel wide. The मतलब thinnest, सबसे ज़्यादा जो हम छोटी से छोटी width वाली, कम से कम width वाली जो line draw कर सकते हैं, that is 1 pixel wide. We will concentrate on drawing a line of 1 pixel resolution only. Resolution is what? The number of pixels to be used in drawing a output primitive. The Cartesian slope intercept equation, as I have told you earlier, that is equation of line is y equals to mx plus b, where m is the slope of line and b is the y intercept. V is the y intercept, where your line will intersect on the y coordinate. The values can be m is equals to y2 minus y1 upon x2 minus x1, and b is the y1 minus mx1. From this we can calculate. Also, for any given interval, that is delta x along a line, we can compute. If we are known the value of delta x from the x1 to the next x1 and from xk to the next xk plus 1, there is a change in the value of x, that is known as delta x. If we know delta x along a line, means we are known the values of x coordinate on the whole line segment. From that we can compute the corresponding y interval, that is delta y. From this equation, delta y is equals to m into delta x, that is nothing, m equals to y2 minus y1 upon x2 minus x1, and y2 minus y1 is called delta x, x2 minus x1 is called delta x. From that we can compute. Similarly, if we know the y interval delta y from along the line segment, we can compute the delta x from that with this equation, that is delta y upon m. These two equations form the basis for determining deflection voltages in analog devices. Line drawing, in the line drawing further, On some raster systems, lines are plotted with pixels and step sizes in the horizontal and the vertical directions are constrained by the pixel separations. Okay, how the pixel is separated from each other. Hence, we ought to sample a line at discrete positions. One position, then the second position. In between, there is no sample. At discrete positions and determine the nearest pixel to the line at each sampled position. If we could draw the lines with positive slope, means 0 to 1 from this area, from 0 to 1. Here the slope is 0, here the slope is 1 up to this area. If we could draw the lines with the positive slope for this area, we would be done. For a line with negative slope, this area is the line negative slope, this total area, and this in this area the lines will have the negative slope. This is and second quadrant means. For a line with negative slope, the value of the slope may be from 0 to 1 only, 0 to -1 from this. For the second quadrant का ये वाला जो part है, this portion के लिए जो line है, if we have drawn line with positive slope, then from those coordinates only we need not to recalculate the another values for the negative slope. We can only negate the y values. We can see that the x coordinates are same and the y coordinates are negated from these values. And for a line with slope that is greater than 1, for the first quadrant का ये वाला portion and the second quadrant ये वाला portion less than -1. This one portion के लिए we just swap the x and y axis. This is the line symmetry, that is the how line symmetry helps in reducing the calculations. All the coordinates need not to be calculated, we just need to calculate the points coordinates for the line having the positive slope between the area 0 to 1. So, this is the code for drawing a line. If we are to invert and draw the integer x y, we just draw pixel with the x comma minus y. If we are to draw the line with the negative slope, we have to invert the value of y coordinate only. And if we are to draw the lines in the upper side area, that is from -1 to +1 slope area, we are to swap the x y coordinates. Swap x y, draw x and y, just draw pixels with the y comma x. The x and y coordinates are swapped with each other. And if we are to draw swap x y invert, both the line is with the negative slope also and within the area of the third and fourth quadrant, we are to draw the pixel with the swapping of the x and y coordinates also, and the x coordinate will be inverted here. This is another code. This is the code you can read out later on. Then the basic line and circle algorithms. There are some properties which are as follows: must compute integer coordinates of pixels which lie on, या तो वो line के ऊपर pixel lie करे और near a line or circle. The algorithm we will use for drawing lines or circles, they must compute the integer coordinates of pixels which lie on or near the line or a circle or any other output primitives. The pixel level algorithms are invoked hundreds or thousands of times when an image is created or modified. Lines must create visually satisfactory images. The lines should appear straight, lines should terminate properly, line should have constant density, the brightness of the line should be same, whether that is a horizontal line, vertical line, diagonal line or anything. Line density should be independent of length and angle, and the line algorithm should always be defined properly. There should no be staircase, jagging effects or unequal brightness. Intensity changes, scanline algorithms have a problem, that is intensity changes based on the line slope. If a line slope is having 0, then intensity will be like this, the continuous constant intensity will be there. As the line slope will change to the upper side, the intensity of the line will be blurred like this, changes like this. The line segment in a scene is defined by the coordinate positions of the line endpoints. This is the first point, this is the second point. there is a line which is from 3 to the two endpoints are given here. This is a 3 2 first endpoint, first starting point is 3 comma 2. 3 is the x coordinate value and 2 is the second y coordinate value. This is the first pixel and the last pixel is 9 x coordinate and 6 is the y coordinate. We are to define which intermediate pixels in between these 2 points will be turned on and which will be turned off, so that a line should be appear straight and the other qualities I have mentioned earlier between these.